Scene script. Have you ever wondered why the universe seems to exhibit a remarkable level of order and balance? The cosmos, in all its vastness and complexity, appears to operate with an uncanny precision, a ballet of celestial bodies and energies guided by unseen hands. But what are the forces that choreograph this cosmic dance, and why does everything seem to fall so perfectly in place? Today we delve into the secrets of our cosmos. The universe's perfection is not a mere stroke of luck or a random miracle. It's a grand design woven by the threads of fundamental laws and constants, a masterpiece painted on the canvas of space-time. The more we explore the cosmos, the more we uncover its intricate patterns and symmetries, the echoes of an underlying order. From the smallest particles to the largest galaxies, everything in the universe adheres to a set of rules, a cosmic playbook, if you may. These rules, the laws of physics, govern the interactions and behaviors of all matter and energy. They are the architects of the universe's structure, the composers of its cosmic symphony. But what gives these laws their form? What sets the speed of light, the strength of gravity, or the charge of an electron? These are the fundamental constants of the universe, the unchanging numbers that define the nature of our reality. They are the dials that set the universe's physical properties, the parameters that shape its evolution. Yet the universe's perfection goes beyond its laws and constants. It's a delicate balance, a fine-tuning of cosmic proportions. A slight tweak in any of the fundamental constants could lead to a universe vastly different from ours. Perhaps one where stars, galaxies, and life as we know it could not exist. So why is our universe the way it is? Why does it seem so perfectly tuned for complexity and life? As we journey through the cosmos, we'll explore these questions and more. We'll delve into the concepts of the anthropic principle, the multiverse hypothesis, cosmic evolution, and the roles of dark matter and dark energy. We'll examine the emergence of complexity, and we'll ponder philosophical and theological perspectives on the perfection of the universe. So buckle up, space explorers, for an exciting voyage into the heart of our perfect universe. In the vast cosmos, certain constants and laws hold sway. These are the fundamental constants of the universe, the unchanging numbers that underpin our reality. Among these are the gravitational constant, which dictates the force of gravity, and the speed of light, an unvarying speed limit that not even light itself can exceed. These constants are the cosmic DNA, shaping the universe as we know it. But it's not just constants that govern our cosmos. There are also the laws of physics, the rules that dictate how everything from subatomic particles to galaxies behaves. These laws are like the universe's instruction manual, outlining how every piece of the cosmic puzzle fits together. Take, for example, the law of conservation of energy. This law states that energy cannot be created or destroyed, only transferred or transformed. It's a rule that underpins everything from the way a star shines to the way an apple falls from a tree. Then there's the second law of thermodynamics, which states that the total entropy, or disorder, of an isolated system can never decrease over time. It's this law that gives time its arrow, pointing us always towards the future. And let's not forget Einstein's theory of relativity, which revolutionized our understanding of space, time, and gravity. It's thanks to this theory that we can understand the vast scales of the universe and the warping of space-time around massive objects. These laws and constants are the cosmic glue holding everything together. They create a universe that is remarkably fine-tuned, where everything from the size of an atom to the lifespan of a star is dictated by these unchanging principles. It paints a picture of a universe that is orderly and balanced, a universe that seems in many ways perfect. But why is this the case? Why do these laws and constants take the form they do? And can they help us understand why the universe appears to be so perfectly fine-tuned? As we delve deeper into the cosmos, these are the questions that guide our exploration, driving us to uncover the secrets of the universe's perfection. What if I told you that the universe is finely tuned? Now, this isn't a claim about a grand cosmic orchestra, but rather it's an observation about the precise balance of conditions necessary for life as we know it to exist. This is the concept of fine-tuning in cosmology. Imagine the universe as a room filled with dials, each representing a fundamental constant. The speed of light, the strength of gravity, the charge of an electron, and many more. Each of these dials is set to a very specific value. If we were to change the setting of just one of these dials, even by the tiniest fraction, the universe would look incredibly different. Take gravity, for instance. If it were just a smidgen stronger, stars would burn out too quickly and violently for life to develop. On the other hand, if gravity were a tad weaker, stars might never form at all. The same goes for the other constants. Slight changes could lead to a universe with no atoms, no stars, no galaxies, and certainly no life. This precision is astonishing. It's as if the universe has been engineered, fine-tuned to allow for complexity and life. A slight turn of any of those dials, and we wouldn't be here to ponder about it. Of course, this raises a big question: why? Why are these constants set to these exact values? Is it just a cosmic coincidence, or is there a deeper explanation? Some propose a designer, while others suggest a multitude of universes, each with different dial settings, but these are topics for another scene. For now, let's marvel at the remarkable precision of our universe. It's like walking a tightrope across the cosmos, where a slip in any direction could lead to a vastly different reality. But here we are, in a universe that seems to have balanced itself just right for us to exist. So when we gaze up at the night sky and marvel at the vastness of the universe, let's also appreciate the precision. The universe, it seems, is not just massive and majestic, but also meticulously fine-tuned. Our universe is a masterpiece of precision. Our existence is not a mere coincidence. This statement is the heart of the anthropic principle, a concept that has sparked countless discussions among scientists and philosophers alike. The anthropic principle comes in several flavors, but at its core, it suggests that the universe's fundamental properties seem to be fine-tuned for the emergence of life because we, as conscious observers, exist to observe it. It's not that the universe was designed with us in mind, but rather, if the universe were any different, we wouldn't be here to ponder its existence. Consider the Goldilocks zone, the region around a star where conditions are just right. Not too hot, not too cold, for liquid water to exist. It's a perfect example of the anthropic principle at work. Earth happens to be in the sun's Goldilocks zone, and it's no surprise that we find ourselves here on a planet capable of supporting life. Let's dive deeper. If the force of gravity were even slightly stronger, stars would burn out too quickly for life to develop. If it were weaker, stars wouldn't form at all. Similarly, if the strength of the electromagnetic force differed by even a small fraction, atoms could not exist, let alone complex organisms like us. The universe seems to be balanced on a razor's edge, perfectly tuned for life to exist. But it's crucial to understand that the anthropic principle does not claim that the universe was designed for us. It merely points out that we should not be surprised to find ourselves in a universe that allows for our existence. After all, if the universe were not compatible with life, we wouldn't be here to observe it. It's like finding yourself in a tailor-made suit. The suit fits you perfectly, not because it was designed with you in mind, but because you were the one who picked it out from thousands of options. Our universe is the suit that fits us, and we're here because we picked it out from the cosmic wardrobe. We are here because the universe allows us to be. Remember, our existence is not a fluke, but a result of the universe's fundamental properties. Our consciousness is the universe experiencing itself, and that's a thought worth pondering. Imagine not one, but an infinite number of universes. This sentence might seem like it's straight out of a science fiction novel, but it's actually a concept that some physicists and cosmologists take very seriously. Welcome to the realm of the multiverse hypothesis. The multiverse hypothesis is a theory that proposes the existence of multiple or even an infinite number of universes, including the one we inhabit. Each of these universes, or bubble universes as they're sometimes called, could have different physical laws, different constants of nature, or even different dimensions. Why consider such a seemingly outlandish idea? Well, it comes back to that apparent fine-tuning we talked about earlier. If there are an infinite number of universes, each with potentially different physical laws and constants, then it's not so surprising that we find ourselves in a universe that happens to be just right for life. After all, With an infinite number of universes, every possibility is likely to be played out somewhere. But before we get too carried away, it's important to note that there are different versions of the multiverse hypothesis. Some versions suggest that the other universes are just beyond our cosmic horizon, forever out of our reach. Others propose that they exist in higher dimensions, or even that they're parallel to our own, separated only by a thin veil of quantum reality. Of course, the multiverse hypothesis is not without its critics. Some argue that it's untestable and therefore unscientific. Others worry that it leads to a kind of cosmic nihilism, where everything is possible and nothing is special. But like it or not, the multiverse hypothesis is a serious contender in our quest to understand why our universe appears to be so finely tuned. And who knows? Perhaps one day we might even find evidence that we truly are just one universe among many. In the grand scheme of things, our universe might be just one among many. From the Big Bang to today, the universe has been evolving. This journey of over 14 billion years is a tale of extraordinary transformation, from a singularity of unimaginable heat and density to a cosmos teeming with galaxies, stars, and planets. Let's step back to the very beginning, the Big Bang. This monumental event wasn't an explosion in space, as the name might suggest, but rather an explosion of space. It set the stage for the formation of everything we know. In the first few minutes, the universe cooled enough for protons and neutrons to come together, forming the first atomic nuclei in a process known as nucleosynthesis. As the universe continued to expand and cool, these nuclei captured electrons, creating the first atoms, predominantly hydrogen and helium. These atoms eventually clumped together under the force of gravity, birthing the first stars and galaxies. With stars came the process of stellar nucleosynthesis. Inside these cosmic furnaces, lighter elements fused into heavier ones, creating nearly all the natural elements we see today. When these stars exhausted their nuclear fuel, they died in spectacular supernovae, scattering their enriched contents across the universe. These materials became the building blocks for new stars, planets, and eventually life itself. Fast forward to today, and we find ourselves in a universe of remarkable structure and complexity. Galaxies are strung out along vast cosmic webs, the large-scale structure of the universe shaped by the interplay of gravity and dark energy. This cosmic evolution paints a picture of a universe that is far from random. From the uniform glow of the cosmic microwave background to the distribution of galaxies in the cosmos, we see evidence of order and structure on an immense scale. These patterns are a testament to the underlying laws of physics that govern the universe. They hint at an intricate cosmic dance, choreographed by natural forces, playing out over billions of years. The universe, much like life, is a story of evolution. From the primordial soup of the Big Bang to the rich cosmic tapestry we observe today, the evolution of the universe is a tale of transformation, complexity, and profound beauty. In the cosmic theatre, dark matter and dark energy play crucial roles. These unseen actors hold the universe's grand narrative in their grip, shaping its large-scale structure and influencing the overall cosmic balance. So what exactly are these elusive phenomena? Well, dark matter, despite its ominous name, is not something out of a science fiction novel. It's a form of matter that does not interact with light or other forms of electromagnetic radiation, making it invisible to our current detection methods. Yet, we know it's there. Its gravitational effects influence the rotation of galaxies and the clumping of matter, providing the cosmic scaffolding upon which galaxies are built. Meanwhile, dark energy, a term as enigmatic as the phenomenon it describes, is an unknown form of energy that permeates all of space. It's believed to be the driving force behind the universe's accelerated expansion. If dark matter acts as the universe's architect, dark energy could be seen as the fuel propelling the universe's relentless expansion. Together, dark matter and dark energy make up a staggering 95% of the total mass energy content of the universe. The stars, planets, galaxies, and everything else we can see and touch, they account for a mere 5%. Imagine that for a moment. Most of the universe is made up of something we can't see, can't touch, and still don't fully understand. Yet without these unseen forces, the universe as we know it would not exist. Galaxies wouldn't form, stars wouldn't shine, and we sentient beings capable of contemplating our place in the cosmos wouldn't be here. So while dark matter and dark energy remain largely a mystery, their influence is undeniable. They are the unseen hands constantly at work, sculpting the cosmos into the grand spectacle we observe today. Invisible to us, dark matter and dark energy are the unseen hands sculpting the cosmos. The universe is not just ordered, it's complex. From the smallest atom to the grandest galaxy, the universe is a symphony of complexity. This complexity didn't just pop into existence, it emerged gradually over billions of years. How so? It all comes down to the laws of physics. These laws, like gravity and electromagnetism, govern how particles interact and form larger structures. Simple particles come together to form atoms. Atoms bond to create molecules. Molecules combine and evolve over time, creating everything from the air we breathe to the cells in our bodies. On a larger scale, gravity pulls matter together to form stars, galaxies, and the vast cosmic web that structures the universe. And within this intricate dance, life emerges, adding yet another layer of complexity to the cosmos. This relentless march from simplicity to complexity is one of the most striking features of our universe. It's a testament to the power and elegance of the fundamental laws that govern our reality. Complexity is the universe's language, and we are its words. The universe's perfection has sparked philosophical and theological debates. Some philosophers see the universe's order and beauty as proof of the existence of a grand designer, an entity that purposefully orchestrated the cosmos. This perspective posits that the universe's perfection is not accidental, but the result of a deliberate act of creation. On the other side of the spectrum, there are those who propose a more naturalistic view. They argue that the universe's perfection is not necessarily indicative of design, but rather the outcome of natural processes guided by the laws of physics. Theological interpretations often intertwine with these philosophical perspectives, adding layers of spiritual and metaphysical dimensions to the discourse. Some religious traditions view the universe's perfection as a testament to the omnipotence and wisdom of a divine being. In essence, the universe's perfection is a canvas on which different beliefs paint their interpretations. It continues to inspire wonder, provoke thought, and fuel our quest for understanding. The universe's perfection is a tale of balance, order, and complexity. We've journeyed through the fundamental constants and laws of physics that shape our cosmos, and explored the fine-tuning that makes our universe just right for life. We've pondered the anthropic principle and the constraints of our very existence on our observations. We've traversed the realms of the multiverse hypothesis and followed the cosmic evolution from the Big Bang to the present day. We've delved into the mystery of dark matter and dark energy and the crucial role they play in the large-scale structure of the universe. We've witnessed the emergence of complexity, from simple particles to galaxies and life. And we've reflected on different philosophical and theological perspectives on the perfection of the universe. So, as we conclude, let's encourage our minds to continue contemplating the question of why the universe appears to be perfect. As we gaze at the night sky, remember we are part of this grand cosmic ballet.